Operations with algebraic fractions. We can do with algebraic fractions everything we did with numerical fractions in the third chapter of this course, including addition, subtraction, multiplication, division, raise in power, etc. Moreover, we can apply with them the new things explained in the current chapter such as simplification, expanding, factorization, etc. Let's have a closer look at each of these operations. A. Simplifying algebraic fractions. Simplifying an algebraic fraction means removing the same number, variable, group of variables, number-variable combination or expression from both numerator and denominator in order to obtain a simpler algebraic fraction. An algebraic fraction can be simplified only when its numerator and denominator represent a single factor, or a product of factors. For example, the algebraic fraction, we have the following shown on screen. This cannot be simplified in the actual form unless its denominator is written as a product of factors. We achieve this through factorization, i.e. we have the following shown on screen. Now, both parts of the given algebraic fraction are expressed as a products of factors. Therefore, we can simplify 2 from both sides to obtain the following shown on screen. Obviously, the common factor must not be a disallowed value. Example 1. Simplify the following algebraic fractions, we have the following shown on screen. Solution 1. Let's try to identify common factors in the numerator and denominator. First, we spot the number 4 as a common factor for the numerator and 3 for the denominator. We have the following shown on screen. Now, it is easy to see that for 3x minus y not equal to 0, we can simplify the expression in brackets to ultimately obtain the following shown on screen. It is easy to identify 4xy as a common factor for this algebraic fraction. Thus, we have the following shown on screen. Simplifying the common factor means we have the following shown on screen. Obviously, this simplification is valid for x not equal to 0 and y not equal to 0. It may seem that the new algebraic expression obtained after simplification is as equally long as the original expression. However, if you look carefully at the powers, you will notice that the variables are in a lower power than before, which means that the expression is successfully simplified. B. Simplifying algebraic fractions using the special algebraic identities. It is good to check whether any of the 8 special algebraic identities is present in any part of algebraic fraction or not. If it is, this would help a lot in the process of simplification. For example, in the algebraic fraction we have the following shown on screen. It is easy to see that the numerator contains the expanded form of the square of a difference, while the denominator contains the expanded form of the product of conjugates. Hence, we have the following shown on screen. Thus, for x not equal to 2, we can simplify x minus 2 from both sides to obtain the following shown on screen. Example 2. Factorize the following algebraic fractions, we have the following shown on screen. Solution 2. The numerator shows the expanded form of the expression x minus 1, x squared plus x plus 1. Thus, we can write the following shown on screen. Simplifying x squared plus x plus 1 from both sides yields, we have the following shown on screen. The greatest common factor of the terms in the numerator is 3xy, while in the denominator it is just y. Thus, we have the following shown on screen. We can use the method explained in the previous tutorial to factorize the numerator. Since it contains a quadratic expression where a equals 1, b equals 4 and c equals 3, p, q equals 1, we have the following shown on screen. We also obtain the following shown on screen. Thus, m equals -1 and n equals -3. Hence, the expression in the numerator becomes the following figure shown on screen. Or we obtain the following shown on screen. As for the denominator, it is clear that the expression in brackets represents the expanded form of x minus 3, x plus 3. Hence, we obtain the following shown on screen. Simplifying x plus 3 from both sides, with the condition that x not equal to 3 yields, we have the following shown on screen. C. Adding and subtracting algebraic fractions. We can add or subtract algebraic fractions in the same way as we do with numerical fractions. Thus, if fractions have the same denominator, we simply add or subtract the numerators while the denominator doesn't change. On the other hand, if the denominators are different, we turn all fractions at the same denominator and only then do we continue with the rest. Let's explain these procedures through examples. Example 3. Do the following operations. Simplify when necessary. We have the following shown on screen. Solution 3. First, we check for any possible simplification, then we continue with the rest of steps. We have to simplify x from the first algebraic fraction and xy from the second. You may think that we can also simplify 2 from the second fraction, but we don't include 2 in simplifications to obtain 2 fractions with the same denominator. Thus, we have the following shown on screen. We do the necessary simplifications in the second algebraic fraction first. We have to simplify m squared n squared from both terms to obtain the following shown on screen. Now, we can multiply both terms of the second algebraic fraction by 5 to turn it at the same denominator to the first fraction. Thus, we have the following shown on screen. The denominator of the first fraction is the expanded form of x minus 3, x plus 3. Moreover, we can factorize 5x from the numerator of the same fraction to obtain the following shown on screen. Now, we can simplify x minus 3 from the first fraction with the condition that x must be different from 3. In this way, we obtain the following shown on screen. D. Multiplying and dividing algebraic fractions. It is worth re-emphasizing that the multiplication and division of algebraic fractions is carried out in the same way as we do with numerical fractions. Thus, in multiplication we multiply the numerators with each other. The same procedure is also carried out with denominators. Then, you can check for any possible simplification. As for the division of algebraic fractions, first the second fraction is inverted down to turn the division into multiplication, followed up by the multiplication procedures. Example 4. Do the following operations. We have the following shown on screen. Solution 4. It is easy to see that the denominator of the second algebraic fraction represents the expanded form of the product of two conjugates, 3x minus 2 and 3x plus 2. Hence, we write the following shown on screen. At this point, we can simplify 6 and 3x minus 2 from both sides of the resulting fraction to obtain the following shown on screen. First, we have to invert down the second fraction to turn the division into multiplication. We have the following shown on screen. Now, if we look carefully at the denominator of the first fraction, we can detect a familiar expression. Indeed, it is the expanded form of the special algebraic identity. We have the following shown on screen, where a equals 2x and b equals 3. Hence, we write the following shown on screen. Now, it is easy to understand that we can simplify 2x and 4x squared minus 6x plus 9 from both sides of the resulting fraction to obtain the following shown on screen. Splitting an algebraic fraction in two component algebraic fractions. Sometimes, it is necessary to do the inverse action of the addition or subtraction of two fractions with different denominators. In other words, we may need to split an algebraic fraction into two other algebraic fractions which, when combined together, through addition or subtraction, give the original fraction. We will explain how to do this by taking the result of the last example as an illustration. Thus, for example, let's suppose that we are required to split the algebraic fraction. We have the following shown on screen. In two algebraic fractions that are related through addition. In other words, we want to express the given algebraic fraction in the form shown in the following on screen, where a and b are, for now, unknown algebraic expressions. In general, we have the following shown on screen, where e, m, and n are three different algebraic expressions. We can express it in the form shown in the following on screen. We obtain the following shown on screen. From the properties of fractions addition, it is clear that we obtain the following shown on screen. Expanding the new expression obtained means we obtain the following shown on screen. We also have the following shown on screen. Since the numerator of the original fraction is 1, it is clear that there is no variable x involved there. So, we can write the following as shown on screen. We also have the following shown on screen. In addition, we have the following shown on screen. Hence, we have the following shown on screen. Therefore, we can write the two component fractions of the original as the following shown on screen. Proof. Let's start from the last expression obtained. Thus, we have the following shown on screen. This is identical to the original algebraic fraction we took as example. Example 5. Write the following algebraic fractions as sum or difference of other algebraic fractions as the following shown on screen. Solution 5. We have the following shown on screen. In addition, we have the following shown on screen. Combining the like terms, we have the following shown on screen. We also obtain the following shown on screen. From the last equation, we obtain the following shown on screen. Substituting this value to the previous one, we obtain the following shown on screen. Hence, the original algebraic expression can be written as the following shown on screen. We have the proof shown in the following on screen, which is identical to the original algebraic fraction. We have the following shown on screen. Moreover, we have the following shown on screen. So, A equals B. Thus, A plus A equals 5, which yields A equals B equals 5 out of 2. In this way, the expression becomes the following as shown on screen. We have the proof shown in the following on screen, which is identical to the original expression. F. Raising in power algebraic fractions. We can raise an algebraic fraction in power by raising the numerator and denominator separately. In this way, we may apply the following property of powers. We have the following shown on screen. Any negative exponent makes the algebraic fraction invert down, and the new exponent has the same value but positive, i.e. we have the following shown on screen. We will discuss the properties of exponents more extensively in the next chapter, so for the moment we are stopping here with them. Example 6. Complete the following operations. We have the following shown on screen. Solution 6. We have the following shown on screen. We have the following shown on screen. Sometimes, raising an algebraic expression by a given power may be beneficial because, as we will see in the next chapter, raising a negative number at an even power makes it positive. This property, as well as many others, may help in simplifying part of the algebraic fraction that could have not otherwise been possible to simplify after having raised it in an even power. Let's consider an example to clarify this point. Example 7. Complete the operations and simplify where possible. We have the following shown on screen. Solution 7. At first glance it looks that there is nothing to simplify after raising the expression in the given power. However, if we express the numerator as the following shown on screen, we can write the following as shown on screen. We can simplify x minus 1 from both sides first for easier operations, obviously, with the condition that x not equal to 1. Thus, we have the following shown on screen. The last expression, or the penultimate one if you want, are simplified versions of the original expression. Such a simplification could not have been possible without the trick of the negative sign. Sometimes we must check for other options to simplify an expression in addition to the traditional options. That is all for lesson 6.5.2, and the end of chapter 6. To continue this mathematics topic, please watch 7, Introduction to Powers and Roots. Thank you for watching. Make sure to like and subscribe to keep up to date with new videos. For more information, calculators, and tutorials, please visit www.icalculator.info.